Good morning everyone. So this is our third video for this project. Uh, from the last video, we finished calculating our concrete structure. This is our concrete structure that we calculate, and also including the cost estimation for this item. So the next item that we are going to take up is reinforcing bars. So this item, we need the total weight of the reinforcing bars that we are going to use in the project. So everything, or all the reinforcing bars, we will compute 2 kilogram. So we will start with footing. For the footing, we will check our AutoCAD files again for our reference. So this is our footing. We have 1.2 1.1, then plus 0.2 at the side times 2. So the diameter is, we will put 16 mm, 0.016 in meter. Then our weight is, the formula of our to get this one is pi d squared over 4 times the unit weight of the steel. So pi times d squared over 4, pi d squared over 4 times the length pi d squared over 4 times the length times 7850. So our weight for one piece of 1.5 meters of steel is 2.37 kilograms. So the parts, we will just count here. How many? 2, 4, 6, 8, 9. 9 times 2, both parts, times 2. Then we will multiply it by 6 because we have 6 columns. So it is 108. Then multiply it to the weight. Our total weight for the footing is 255.69 kilogram. So our next next part is, we will compute the slab. For the slab, we have a drawing here. Okay. For our slab, we will first take this one, 5.8 meters. 5.8 meters. Then we have 12 mm. Then we will take the formula here. Then the parts is, how many this one? 2, 4, 6, 7. Wait. 1, 2, 3, 4, 5, 6. 6, 7. Okay. Then the total weight is 36. The next is this one, 4.18. The average, we will just get the average of this one, so that we will not put this one by one. So we will just get the average, and we will count the number of bars. It will be the same, guys. So 4.18, then 12 mm again. The weight is, formula, copy from the top. Then number is, this is the last bars that we included in the last calculation. So we will start here, 1, 2, 3, 4, 5, 6, 7. So it's 7 again. So the weight is 25.98. So the next one is this part here, starting here, going here. So 3.9, then 12 mm again. The weight is that one. So count 2, 4, 6, 8. So it's 8. The total weight is 27.7. So for this one, 5.4 meters, this horizontal bars here, guys, this horizontal bars, 0.012, the weight is copy from the top only, guys, because this will be the same here. We will just making the formula. Then number of bars, 1 2 3 4 5 6 7 8. So wait, 2 4 6 8. Okay, so the total weight is 38 for these 5 point meter long bars. So the next one is the beam. For the beam, we have B1. I just put this one here, B1, B2, B3, and B4, B6, because we have 6 beams. Okay, this is our, assuming this is the design of the beam. Actually, guys, in the actual plan, there is already including the cutting list of the steel, so you just refer your quantities there, but do not copy directly, because some cutting lists are incomplete, so you have to understand you are going to put in your quantity. You might be losing quantities if you will not check that one, or you will be putting more bars. So for this one, I will just calculate my computation roughly, because this is just, but actually it will not differ very differ large amount of quantity if we just consider everything, and we will not forget, and we will not add of the quantities. We will just roughly estimate the number of bars and the length of the bars. It is not exactly, but as I said, if you have a proper plan, you can see there in the cutting list the exact length of the bars. So for the beam 1, this is 5 meter, guys, so I will just add 0.25 here and 0.25 there at the other side. So plus 0.25 times 2, because the other side plus 5 plus 5 meters. Then I will just add 0.5, guys. So I cannot maybe some, what is this, some splicing of this one, so I just add 0.5 for every bars that I will make. Okay, then if this is our at support, we will just count this one, guys. So 2 4 6 8 9, so I have 9 bars. So I'll just assume that all this one is continuous, because I am just calculating the quantity, guys. I will not put it as it is in the plan. Okay, so meaning if we have cut here, but it will continue here also at this side, so it's almost the same. I will just add some percentage so that I will not be losing quantity. Okay, so this is 16 mm and 0.16. Then the height is the, what is this? Wait, this is height. This, the weight is, let's just copy here. Okay, the formula, and the parts is how much, that one, 9. So the weight of that one in beam 1 is that one, 85.83 kilograms. So we will compute the ties. ties is ties. We will refer to the drawing again. 0.3 times 2, then 0.147 plus 0.3 times 2 plus 0.147 times 2, then we will add 0.054. I think we will just put 0.1 meter for the additional length, because it is not exactly rectangular. It has a in part that will tie to the main bars. It will go here. If we have, it will do like that, guys. Will do like that. This one here also like this. So like that. So we'll count this one is together. It is 0.1. Okay. But as I said, guys, this is only a rough estimate. If you will be doing your estimate, you should especially for the quantities, you need to refer that one to the cutting list of the drawing or the plan. 0.2, 0.3, so this is 16 mm again, and the weight is that one, so the numbers is, actually we will just count this one, because this is the stirrups of the beams. Then 1 0.05, then 5.1, then 5 pieces 0.15, then rest to 0.2 meters. So for this one, 1 plus 5 plus 5 is 11. So both sides we have 11 times 2, then plus, wait, 11 plus 11 times 2 plus, guys, we will just make a formula for that one so that we can just follow that one afterwards. So if that is if this is the we will just put it here, guys. 11 times 2 plus this 2 here, 5, we will put 5. This one, the 5 meters length, we will minus this 1.15 times 2, so 2.3 minus 2.3 minus 2.3, then 2.7 divided by 2, because it will rest at 0.2 meters. 2.7 divided by 5 minus 2.3 divided by, we'll just enclose this one to parentheses, divided by 0.2 meters. So how much? 15.5. Wait lang, wait. 11 times 2 minus, we'll make 8 this one properly so that we can just copy this one later. So 5 minus 2.3 5 minus 2.3, ay, wait, I'm already confused. 5 minus 2.3 is, wow, we will include this one. 5 minus 2.3 divided by 0.2. So this is not like this, guys. So then we will round this one up, round up. We will start, okay, round up to 0. Okay, so 36 bars. So we will check 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36 exactly. So this is 36 bars. So the parts, the ties is 56 kilograms. Wait, this is only 10 mm, 0.01. Okay, so for the beam 2, we will just copy only this one, beam 2. Then we will wait, we will just check the beam 2 is 2.5 meters. So we'll just change this one 2.5. Okay, and this one, number of pieces, this one is 2 point, how much is it? 2.5. So it's 23. For the beam 2, it's 23 pieces of ties. So for this one, actually, guys, this beam 2, I only put 3, 6 number of horizontal bars. This one, this main bars, we have 3 at the top and 3 at the bottom. Okay, because this is shorter than this one. This is 5 meters and this one is 2.5 only meters, so it should be economical. Okay, this is 6, this is beam 2. Okay, then the beam 3, check from the drawing, it's 4 meters, so we'll make it 9 also. We will just copy this one. Okay, then beam 3 is 4.003. The number of bars will put this one 4.003. So that one. So for the beam 4, beam 4 is 2.2 meters. So we will just put this one 2.2 meters. Then we have 6 number of bars, main bars. Then we'll just put 20 here, 2.2. So it's 22. Only 22 number of ties. So for B5, 2.75. Okay, we'll put that one here, B5, and 6 number of bars, 2.5 this one, then this one 2.5. Okay, then B6, B6 2.5 again, the same. Yeah, this one is 2.75. B5 is 2.75. Okay, 2.75 this one. Okay, so that is for the beam. Next we have column. Anyway, guys, if you have a plan that is properly having the cutting list, it is easier for you to calculate for this one. Okay, for the columns, we have here the column. Wait, guys, This is the column. We have 4 main bars, 16 mm main bars. This is one story only, guys, so I just put this one 60, but actually the standard already we need 6 at least of at least of vertical bars or the main bars for the column. I just put it 4 bars, column 4 bars. So the length is just let me see how much length that one. 4.6 meters. 4.6 meters. I'm confused with this one, guys, so I'll just do like that. 4.6 meters, then 16 mm again, 0.016. Then the weight is, then the number of parts is 4 times 6. Okay, 6 because number of columns is 6, so the weight is 174. Okay, the weight, guys, is I just follow this formula so that you can just copy this one down. No need to calculate again every length. So the number of tie bars, you just count this one. You can make a formula, but this one is the same all columns, so we just count this one: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we have 26 bars. And how much length of the ties? 0.2 times 4. We'll just put plus 0.1, then 10 mm. So the weight is this one, so the total is, this one is ties. Okay, so the next one is the small column at parapet wall. Okay, its length is 1.13. You just refer from this one, guys, so 1.025 or 1.13. then just put is 12 mm. Then weight is this one. Okay, number of parts, I just put it parapet columns in parapet walls. This is under column. Okay, so 4 times 6 again, so 24. Why is this 26? This is the ties, so the weight total is for 24 kilograms. And the ties is 0.1 plus 0.1 times 4 plus 0.1. Okay, and 0.01 ties weight. Then the number of ties, 2, 4, 6, 7, 8 equals 8 times 6. So the total weight, of the steel starting from the footing is 997 kilograms. Anyway, guys, there is still reinforcing bars in hollow blocks, but in unit costing in hollow blocks, the reinforcing bars is included there in per square meter, so we will no longer put it here. Okay, so that it will not become redundant. So it's 997. So for the unit rate derivation of the reinforcing steel, we will need to link the total quantity, which is 997.67 kilogram. So our assumed production, we'll just copy this description here, is 143.44 kilogram per hour. So the materials are deformed reinforcing steel. Then we have 16 number 16 galvanized iron wire. Then we will put consumables of 5% of the materials. So this is like this. Okay, this is deformed bars, the number 16. Then we have 5% of material cost. Material cost meaning 5% of the deformed bars and the galvanized iron. Okay, tie wire. So this one, anyway, for this quantity, guys, it is safe to put one. Actually, usually the wastage is almost more or less 3%. So we will just put 1.033% of times 3% of the total quantity of the reinforcing bars, because we cannot use all the bars that we buy there. We need to cut some of the parts, so there are wastage in reinforcing bars calculation. So for the tie wire, we will multiply up 15%, 1.5%, 0.0115 times the quantity. So this is our the kilogram of galvanized iron that we are going to include. Okay, now we'll just multiply here the quantity. So the rate of reinforcing bars by kilo is 47. So I think this is already 48 now. So but you just verify that one, the quantity, and also the rate of the reinforcing bars per kilo. But for the galvanized iron, I think it's the same, 100 per kilo. So to multiply this one, the rate and the quantity is that one. Then the 5% plus 0.05% times the sum of these two. Okay, wait, 0.05. Then this is the sum of that one. Then we multiply, this is 2000. So we have 52,336 for our materials for our 1027 kilograms, or all the reinforcing bars that we are going to use in that small project that we have. So for the labor, we have construction foreman again, then skilled labor or the steelman, then we have unskilled labor. But for this assumed production, we need one construction foreman, then 3 steelman. Okay, we will just copy this one, the quantity. Okay, we need 1 foreman, then 3 steelman, but we need for this one 12 unskilled labor. So this one piso per kilogram, this one, guys. So this one is per hour because this is labor. So we will compute again the per kilogram, some product of this one, 2, this one, and divided by it to our assumed production, which is 143.44. So we have 5.04 uh, peso per kilogram of steel. So we'll multiply it to the times the quantity. We have 5,175 of labor. So for our equipment we need bar cutter, bar bender, then for the minor tools also. Okay, we need this one, but for bar cutter we need only 0.5 hours, so bar bender also is 0.5 hours. Okay, 0.5 hours for this assume production. This is kilogram per hour, but we will use only 0.5 hour for that production. Okay guys, so this one is 0.1, 10% of labor cost. So this is already there formula. This one, some product of this. So this is the rate. Okay, some product again to get the piso per kilogram of equipment. Then to this rate, then we will divide it to our assumed production. Then we have 2.49 peso per kilogram of this one. We will link our quantity and multiply it to the rate. So our amount is 2,564 for our equipment of 1,027 kilogram of steel. So the same as before, our estimated direct cost is we will just add materials, labor, and equipment. Then unit direct cost, we will divide this one, divide to the quantity, the estimated direct cost divided the quantity, so it's 58.46. So we will no longer put our indirect cost as previous discussed. So our total cost is the same as our indirect cost, and the unit cost work item is also the same as the indirect unit cost. Okay guys, so this is our cost for our steel. So this is for now, and next I think we have formworks. We will compute the formworks of the quantity, then also the unit rate derivation or the cost of the project for formworks. Okay, thank you. See you next video.